ever wondered how refineries predict phase behavior during a sudden pressure reduction? When a liquid mixture experiences a rapid drop in pressure, part of it flashes into vapor while the remainder stays in the liquid phase. Predicting how much of the mixture vaporizes, the resulting temperature, and the compositions of the vapor and liquid phases is a fundamental problem in chemical engineering. This is the problem addressed by this code.
This model handles multiple components, both ideal and non-ideal mixtures. You will be dealing with a non-ideal mixture of 3 components: ethanol as component 1, water as component 2, and methanol as component 3.
Users provide the Antoine constant A, B, and C, critical temperature, and the critical pressure, the eccentric factor, the liquid molar volume at 25 degrees Celsius, and also the feed mole fraction of each component is specified. The user is required to input the system pressure. After that, the user is required to input the Wilson parameter. The Wilson parameters describe how molecules of different components interact with each other, such as the interactions between component 1 and 2, 2 and 3, and 1 and 3, and in both directions.
After all required parameters have been entered, the code proceeds to calculate the flash temperature, vapor fraction, liquid phase mole fraction Xi, vapor phase mole fraction Yi, activity coefficient gamma, which quantify the degree of non-ideality in the liquid phase, and fugacity coefficient phi.
And this is how the model is run for non-ideal mixtures. So on how to run the model for an ideal mixture, we will be running the code for an ideal mixture of 2 components, benzene and toluene. Component 1 is assumed is benzene and component 2 is toluene. So the eccentric factor, the Antoine constant A, B, and C, critical temperature, critical pressure, and the liquid molar volume of both benzene and toluene are imputed as required. The feed mole fraction is also imputed. The system pressure is specified, but for the Wilson interaction parameters, they will be set to 0 because we are dealing with ideal mixtures. After all required parameters are input, the code proceeds to calculate the flash temperature, vapor fraction, liquid phase mole fractions, vapor phase mole fraction, activity coefficient, and the fugacity coefficient. And this is how the model is run for ideal mixtures. This project was presented by Frimpong Kwabena Yeboah
and Ajam Lukramo Harrison.